Hello and welcome. Let's work on a new problem, and you can see at the screen that we are talking about a metal sheet between the capacitor plates, and the statement reads that the vertical plates of the air gap plane capacitor, it's a parallel plate capacitor, air between them, shown in the figure, have an area A and their distance, that means distance between the plates is D. In the middle between them is a thin metal foil of mass M. That's right. The metal foil is connected to a voltage U. Oh, this kind of voltage U in position 1 of the switch K with respect to the grounded plate 1 first, and the switch is now connected to position 2. Switch is now shifted to position 2. What is the force acting on the metal foil? Yeah, this is the first problem. What is the direction of this force? Well, with what speed will the foil stick to one of the capacitor plates if it is allowed to move freely horizontally? And last part of the problem is, how do you calculate the time it takes for the foil to reach the capacitor plate? And here are some given parameters. So we need to solve this problem, and let's start solving this problem when the switch is at position 1, that is in this position. And now I can see that the capacitor formed by the foil and the plate first has a capacitance equal to, I think, epsilon naught A by D by 2. That means this is the capacitance, and this capacitor is charged to a voltage U. That means charges on the plates on the foil, I can write it QF, that will become CU, that is 2 epsilon naught A U by D. That is the charge on the metal foil, and I now want to find which plate is positively charged and which plate is negatively charged. So since this plate is grounded, that means it will have zero potential, and it is connected to the positive plate of the battery. That means this plate will require that this should be positively charged, but the earth will send the necessary negative charge to bring it at zero potential. That means it is negatively charged, kind of this. It will have negative charge, and then the metal foil will have positive charge. So electric field will be between them will be like this. I think so. What I'm trying to tell you, that the foil has this much positive charge, and there is a minus QF charge on the plate 1. And now if the switch the key, let us switch the key to position 2 here, position 2, and determine the resulting electric field in the position when the metal foil has already moved some distance, because when the switch is being shifted from this position to position 1 to position 2, in between this plate will move some distance. Suppose that this distance is x, then it will move a distance towards the plate 1, a distance x towards plate 1, and in this process charge on this plate 1 and this charge on this metal foil doesn't change, and since this is positively charged and it is going to be connected to its negative plate, that means negative end of the battery, that means an electric field in this direction will be generated. And I can draw a picture for it, that when I switch the key to position 2, then I can see that this metal foil was initially in the middle of the capacitor plates, and then it has shifted a distance, say x, towards the plate number 1, and here is the plate 2, and the distance between the plates were initially d. So this distance has now become d by 2 minus x, and this distance is d by 2 plus x, and there is an electric field in between metal foil and plate 1 like this. Let's call this E1, and the electric field between plate 2 and metal foil will be in this direction. So let's call this E2, and it will be in this direction. And now we can write the voltage between the two plates, and I guess the voltage of, since the voltage source, I need to analyze the voltage source. The voltage, this part of the voltage source has potential equal to 0. Its potential will be equal to 0. So I think its potential, the potential of this plate is EU itself, because this plate is connected to earth, so there is a potential difference, whatever it is, positive, negative, I don't know, but its potential difference will be its potential of this plate is U. So I can write an equation like potential of this plate being U, and so no, the potential of this plate is 0 in fact, because it is grounded, and that means potential of this plate being E1. So I need to write the potential difference between the two plates, and I will starting that suppose that its potential is U1, potential of this plate is U1, and we move towards decreasing potential. Moving from here to metal foil, we are moving towards decreasing potential, and that is against the electric field. That means we are gaining the potential difference, and so when we reach here, we will have the potential U1 plus E1 multiplied by d by 2 minus x, and then we are moving towards decreasing potential. Potential is getting decreased. That means moving from here to here, we are going to lose the potential difference by E2 multiplied by d by 2 plus x, and then we are going to reach at finally reach at potential U, and that is equal to U in fact. And since U1, its potential is equal to 0, since U1 is equal to 0, That means we can write an equation like E1 d by 2 minus x minus E2 d by 2 plus x, and that is equal to u. This is one of our equations. And I can see one thing also, that the charge of the metal foil during its motion from this position to this position is always QF. So we can use the Gauss's theorem here, considering this whole surface, and we can use the Gauss's theorem, and we can write, if we can use the Gauss's theorem around the metal plate, whole metal foil, I can use the Gauss's theorem, and I would like write an equation that this electric field is E1 and this electric field is E2. So I can write E dot ds simply as E1 A1 plus E2 E2A. Both side of area is A, and equal to Q net by epsilon naught, that is QF divided by epsilon naught. So I can write, we can have another equation like E1 plus E2 multiplied by A equals QF by epsilon. QF is already calculated. This is our equation 2, and from these two equations we can calculate the values of E1 and E2, and I guess you will calculate E1 equal to 1 plus x upon d, 2u by d. This is E1, and I think in the similar manner E2 can be calculated, and s is going to be minus x by d 2u upon d. So these are the electric field between the plates. And now we are going to calculate the force acting on the foil. And how can we do this? To do this, I would like to set up our theoretical material. If we have a plain parallel plate capacitor, and the electric field in between them is E, and we need to find out force on this, and the charges are like Q and minus Q on both the plates. Of course plus Q will be here and minus Q will be here, and if we try to calculate the force on this plate, I can simply write this force equal to charge multiplied by electric field produced by this plate only, and that is not E but E by 2. So I can use this idea, and so that I can be able to calculate the force acting on the foil. And I can write it that this force will be, the charge on the foil is QF, and there are two capacitors, and one capacitor is of course in this part and in this part, and there are two electric fields acting on it. So part of QF will be here and part of QF will be here. I can consider both of them together QF, and the electric field is E1 minus E2. So to calculate the force, we have to consider only half of this electric field acting on the metal foil, charges on the metal foil, and I can write is QF E1 minus E2 by 2, and so I can write the value of QF from here, that is 2 epsilon naught AU by D. So the and E1 and E2, E1 and E2, E1 and E2, and I guess the result is going to be 2 epsilon naught AU square by D square 1 plus 2x by D, the force acting on the metal foil, and this force is directly proportional to x. Fx is linear, I can see here, and the direction of the force on the metal foil is towards right, as you can see, and that means towards plate 1. And so first part is being calculated now, and the second part of the problem, we needed to find with what speed will the foil stick to one of the capacitor plates if it is allowed to move freely horizontally. Yeah, that was the second part, and we are now moving to solve the second part of the problem. And I can say that the velocity of the foil after it has traveled a distance x equals d by 2, because it is coming to plate 1, it is going to stick to plate 1. So the velocity of the foil after it has traveled a distance x equals d by 2 can be calculated from work energy theorem. And work energy theorem, I'm going to use the work done by all the forces, that is basically in horizontal direction it is electrostatic forces acting between the plates, and that force on metal plate is already calculated by this expression, and this is the work done by this force is equal to change in its kinetic energy, and its mass m is given, so I can write it half mv square. But to calculate the work done by this force, I'm not going to integrate this, but rather, since force is a linear function of x, so fx dx I need to integrate, and I'm going to take its arithmetic mean from the 0 value to the final value, and multiplied by it the displacement d by 2, and I can simply write work done by this force as force when x is d by 2 plus force when x is equal to 0 divided by 2 multiplied by displacement d by 2, and that is equal to half mv square. And without medium resistance and other friction forces, they are all neglected because they are not mentioned in the problem, and you will get the velocity equal to simply as 3 epsilon naught a u square by md. And this is the second part of the problem. Now we need to move towards the third part. And how do you calculate the time it takes for the foil to reach the capacitor plate? Time. This is inviting you to write a differential equation and solve it, because motion of the foil, due to its increasing acceleration, basically f increases as a function of x, so acceleration from fx, you can see here fx is like this, and x is decreasing, and still the force will keep increasing, and I can say that the motion of the foil, due to its increasing acceleration from place to place, differs from all the motions studied in a high school. The exact determination of the total duration of the motion would require advanced mathematical knowledge, solving a differential equation, and we already know in our country, and integrating the velocity Vx with respect to x. But I can give you some estimates. But if you want to integrate it, you can integrate by yourself. Though I can provide you, if it since its velocity is continuously changing, so when its velocity is maximum and when its velocity is minimum, how much time will it take to reach the other plate 1, I can provide you. But I'm still favoring, in fact, you can go and set up your differential equation, because force is there, mass is there, so acceleration is there, and you can usually manipulate them velocity in terms of velocity as a function of x, and then x in terms of time, and you can calculate the required time. But since it's going to be a cumbersome work without, so this is pure mathematics, no physics in it, so it has been left to you. Thank you very much for watching.